Welcome to Day 12, Section 3.5, Models of Linear Functions. So this is your first experience with models in 490s. There's a couple things that we do in this class that you need to abide by. For the most reasons, it's so that you understand what is going on with the problem. Also, it helps us follow your work and make sure your understanding is up to par. So as I go through this, please make sure you're taking detailed notes. And then when we go over the homework in class in detail, make sure you're also taking notes about point values and where not you might be earning points. Okay, so here we go. This is actually a book problem, so it's on page 92, number 34 if you're interested. Really, it's an introduction to linear models. So Calvin Butterball drives from his home on the farm to a nearby town of Scorpion Gulch. As he drives, his distance from Scorpion Gulch depends on the number of minutes he has been driving. When he has been driving for 6 minutes, he is 17 kilometers away. When he has been driving for 15 minutes, he's 11 kilometers away. Okay, good thing. I first am noticing it says distance depends on the number of minutes. That is extremely helpful for me. It's showing me that distance depends on minutes. Your y depends on your x variable. So your y variable is the number of kilometers, or the distance, and your x variable is the minutes. You always need to have these labeled. If not, we give them to you. Otherwise, they need to be labeled for us to follow your work. And it does make sense that at 6 minutes, he's 17 kilometers away. So from there, we can write the information about distance and time as two ordered pairs. Your x is 16, your y is 17. Then he tracks at another time. When he's been driving for 15 minutes, he's 11 kilometers away. So your x is 15, your y is 11. Again, all depends on you labeling your variables. Okay, next, part B. Assume that the distance, comma time relation is a linear function. Write the particular equation for this function. Transform it if necessary so that the y is by itself on one side of the equation. Now think back to when we talked on day 4. If we don't tell you what form to plug into, find any form, your favorite form, plug it in. This time, we tell you, once you find it, you need to transform it so that the y is by itself. Little details here that you want to make sure you pay attention to. Well, let's think. I have 2 points. Why not do point slope? So let's quickly find the slope between my 2 points. Doesn't matter which one comes first. I'm going to do 17 minus 11 over 6 minus 15. That gives me 6 over negative 9. Always simplify. Here is my slope. I have a point and a slope. The easiest way for me to plug it into is point slope. Doesn't matter what point you choose. For this one, I'll pick this point. No reason. So it's y minus 11 equals my slope, x minus 15. However, the last part that I underlined it in red said transform it so that y is by itself. Well, sadly, in this problem I have, the y has a negative 11 attached to it. So I need to solve for y. First thing you need to do, make sure you distribute your slope. Okay, don't do anything silly. Don't forget this step. That's problem number 1. So what you're going to get, I'll go right here, y minus 11, we still have that, would equal negative 2/3 x. Negative 2/3 times negative 15 is actually positive 10. So not bad at all. Now make sure you add that 11 to both sides. So your new equation becomes y equals negative 2 over 3x plus 21. That is the equation that you will need, and that is how you will get full points on part B. Part C, use the equation, which we just found in red, to predict Calvin's distance from Scorpion Gulch when he has been driving for 24 minutes. Now, luckily I wrote down my variables up there. Well, what does minute stand for? Is 24 minutes the x or the y? Well, looking up here, let x be the number of minutes. So right away, I know I'm trying to find the y when x is 24. Let me take this equation from above. Y equals negative 2/3 x plus 21. I'm going to now substitute in my x value of 24. And I'm solving for the corresponding y. So if I do that, 24, I get y to be 5. Huge thing with models, units matter. We make you write them at the beginning, we make you use them the entire problem. Again, y is kilometers. Just make sure you have the kilometers. Part D, use that equation, again the equation in red, to predict the time when Calvin arrives. So I'm trying to find time. Time is x, the number of minutes. So I know I need to have my x in the equation. That means the y has to be a value I can input. Well, if you go back to the beginning, it says drives from his home on the farm to the nearby town of Scorpion Gulch. As he drives, his distance depends on the number of minutes. He's been driving 6 minutes, he's only 17 kilometers away. As he drives 15, he's only 11 away. Notice as the time increases, the distance away decreases. That should make sense. You're trying to figure out when you get there. In other words, when your distance is 0. So take that equation from above, the one in red. This time substitute in 0 for your y value now, because you know where you are. And this time you're solving for the time. So you would subtract 21 over, you would divide by negative 2/3. So I'm getting, over here, x is going to equal 31.5 units. So 31.5 minutes. Okay, all you're doing is solving for x in that problem. Now, for majority of our models, once you go through the beginning parts, it's now going to ask you to put all that together. Actually put it in a graph using a suitable domain. You need to label your axes, so let's start with that. Back up here, we already know the labels, right? X and Y. So label those quickly on your graph. So this is number of minutes is your X. Your y is your distance. I'm going to write in kilometers. And I know it's going to be linear, so I know it's going to be a line. I know that the slope is negative, so I know it's going to be a negative line. But what else do I do? Well, what you're going to do is take all your points you created. In part A through D, you actually created 4 different points. Let's put all those points together. You have your initial 6,17. You have your 1511. In part C, you created the point 24,5. And at part D, you created 31.5. 0.5, comma 0. That's a lot of different points that we can graph. Now it's important to scale, so don't make it super teeny tiny to the bottom left side. Don't make it too big where those points don't fit on your graph. It should be a very reasonable graph. Now the one other thing I'm missing, here I have an intercept. That's the x-intercept. You really should try to find the y-intercept as well. Okay, that'll help your graph. Well, luckily, if you look back here in part B, we made you solve for that. I know, we're so nice. So you actually create another point, that's the y-intercept of 0, comma 21. So this will help you as you create your scale. I know that my x has to get up to 31.5, and I know my y has to get up to 21. So I'm going to try, it's all trial and error. I'm going to try to go by 2's. I think that's reasonable. So I'm going to write, every line is 2. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and I'll do the same thing for my y. You don't have to do this way. You can actually go every other one, but something reasonable so you can see the graph. 2, 4, 6, 8, 10. I actually probably could have went by ones, but that's okay. You get the point. Make sure you label it so we can clearly see it. Now let's label our points. You have 6, 17, 15, 11, 24, 5, 31.50, and 0, 21. Take a moment, graph those points. Hopefully, if you did it right, you would be able to connect a straight line between them. So that is your first introduction to models. Make sure you take time, go through these in detail. Make sure the answers make sense. It has a negative slope, so it makes sense that the line is decreasing. Make sure you label your axes. Make sure you scale. All these things, you will get a hang of it, don't you worry. But make sure you're taking care of it now. Best of luck.